Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, Asteroid Collision. So with this problem, basically, we have asteroids of integers, an array of asteroids that is in a row, so basically just an array of integers. And for each asteroid, the absolute value represents the size, and then the signs represent the direction it's going in. So if it's positive, it means it's going right. If it's negative, it means it's going left. Okay, and each of them they move at the same speed. So there is no asteroid that is faster than the other. And the goal is to find out the state of the asteroids after all collisions. So basically, since they go in different directions, if two of them meet, the one with the smaller value, absolute value of course, because the sign just represents the integer, the direction, so the smaller one, the one with the smaller value will explode. Okay, and if they are both of the same size, then they will both explode. So, and if they are now moving in the same, moving in opposite direction, so if they are like 5 and 10 here, they will never meet because they are going at the same speed on the right direction. Okay, so that's the problem here. Now if we take a look at the first example, so 5 moves in this direction and 10, but the first two that will meet is -5 and 10. Okay, and so because -5 moves in the opposite direction at the same speed, and so which one is the smallest absolute value? Well, that's 5, so that means 5 explodes. Okay, and then 5 and 10 are moving in the same direction, so they won't meet, and so we are left with 5 and 10. For 8 and -8, they are moving in opposite direction. They have the same value, and so both will explode, and so we'll end up with an empty list. For this one will meet with this one. They have opposite directions, so they will meet. Since this one has the smallest absolute value, this one will explode. And then -5 will meet with 10, because again, opposite direction. And since -5 has the smallest absolute value, this one will explode. So I'll end up with 10. Okay? And so that's sort of the idea here. Now let's see how we can tackle it. Okay, so let's see how we can tackle this. So with something like this example, so the first thing to think about is that the only case where 2 will explode is if you have one moving to the left and the other moving to the right. Okay, that's the only case, because if you have 2 moving to the left, they won't meet. If you have 2 moving to the right, they won't meet, right? You can't have one moving to the if you have 2 moving like this, they can't meet, all right, because they won't meet. So the only case is this one where they will meet. Now what's that case? Well, this case is minus if the value of one to the left of one value is minus, and then this value is positive. So only if the value before was positive and the value after is negative, that they will meet. Okay, so that's the first observation. But the other observation that we saw also in the third example is, if you take a look at this example with 10, 2, -5, what did happen? Well, what happened here is that first -5 met with 2 here, and 2 exploded, but then -5 continued, right, and met with 10, and -5 exploded. Now let's take another similar example just to see another variance. So what if we had 4, 2, -5? So in that case, -5 will meet with 2, 2 will explode. -5 will meet with 4, 4 will explode. If we had another values like 3, 1, those will explode as well. Okay, so basically what I'm saying here is that once you have something moving to the right, it will keep going until it explodes, right? Or it reaches the end of the array. Okay, so how can we represent this? Well, the obvious way, because if we traverse the array from left to right, the obvious way is to use a stack, because then we can put all the asteroid that haven't exploded, and then when we have -5, when we have a negative value, then we can check which one will explode. And so in this specific case, it's the -5 that will explode, and then the stack stays as it is. But in this case, what will happen with 2 and 4, we'll have -5 and 4 will explode. Sorry, 2 and 4. So 2 and 4, so 2 will explode, right? And then we'll check the top of the stack again, and 4 will explode. So we'll keep checking the stack. As long as the value is smaller, it will explode, okay? So that's sort of the idea here. Now, one other case, what if we had, let's say 5, 2, -5, right? So first we'll go to the left, we'll add 5, and then we'll add 2, and now we'll encounter -5. So whenever we encounter a negative value, that means we can have a collision. And so we compare against the top of the stack, 2. The absolute value, the smallest absolute value is the one for 2, and so we pop 2. Okay, and so now we check against 5. Well, they are the same size, so that means both will explode. And so we end up with empty. But in this case, we'll end up adding -5, and then at the end, of course, always we return the stack itself, because that's the remaining elements. Okay, so here, if the one going in opposite direction explodes the others until the stack becomes empty, then we add it. Okay. Okay, so that's pretty much the idea here, is to use a stack to keep track of the ones going to the left. And the only case where there was a collision is if we encounter a negative value and our stack is not empty, right? Because if our stack is empty, let's say, for example, if we had -5 like this, then, or maybe -5 and some other values, let's say 10, 12, then in this case, we'll just put -5. 10 is positive, because the stack is empty, we'll just add it, and 12. Okay? Now this makes sense, because this is going to the left, opposite direction, and this one is going to the right, so they will never meet. Okay? So those are all of the different cases, and we'll just use a stack and just go through the asteroids from the left to the right. Okay, so let's implement this solution and make sure it passes. Okay, so now let's implement the solution. So what do we need? We first need to just have our stack, and then we need to go through the asteroids that we have. So, and now we want to check if it's positive, then we don't need to do anything. We just add it to the stack, right? Because it won't collide with anything. Now, otherwise, which means here it's negative, so there is a collision potentially. So while the stack is not empty, that's what we saw in the overview, and the top of the stack is positive, because if the top of the stack is negative, then there won't be any collision, right? So let's say we had maybe something like -5, -2. So we'll first add -5, and then when we at -2, the top of the stack is negative, so we'll just add -2, because this means that -5 is going in this direction, and -2 as well, so they won't meet, right? And so that means here we have, if it's positive, then we want to pop, but also only when let me go back to the example, only when the top of the stack, right, is smaller than the negative value, the positive value for A. So for example, if we go to the first example, which is 5, 10, -5, so we'll put 5, put 10, but then when we encounter negative value, 10 is bigger than 5, -5, right? So it's 5. 10 is bigger, so in this case, that means the 5 here explodes. This one explodes. Okay? And so 10 stays, we won't pop it. We only will pop it if, let's say we had here 2. 2 is smaller than 5, then 2 explodes, and so we'll pop the top of the stack. Okay, so only if it's smaller that we pop the top of the stack. Okay, and we'll keep doing this, because what if we had 4 here, then we want to pop it off. Okay, if we had 4 here, then we want to also pop off 4. Okay, and now we check if the stack still contains values and the top of the stack is negative. Okay, so that means, for example, in this case, right, when we encounter -2, the stack still contains a value, but the top is negative. That means we should add -2, because they won't meet. The top of the stack and this value A won't ever meet, right? So we should add A to the stack. Okay, now if they are equal, like let's say we had here -5, or even 5 or -5, both work the same way. So if it's like this, then we want to add, we don't want to add A, because they have the same value, so both explodes. So this one we want to remove it. And the same way, if it was -5 here, they still have the same value, absolute value, and so both explodes. And so both explodes means we don't add A, but we also pop the top of the stack. And so in this case, if they are equal, so if this is equal to -A, then we want to pop the top of the stack. Now at the end, we want to return stack. Just return the remaining element. So let's see. This should be equal. And looks good. Let's submit. Looks like there is a... So this is OR, right? Either the stack is empty, like initially, let's say the first element, or the top is negative. Then we want to add the new element. Okay, let's submit. And this got accepted. Okay. Now, if we look at the time complexity here, since this stack pop operation will run at most the number of asteroids, because once we pop an element, we won't put it back. And so overall, we are guaranteed that this while loop will not run more than O of n times, n being the number of asteroids, because we will never put again an element back in the stack. We will only put the number of elements in asteroids. And so this basically tells us that this will run at most overall, even inside this loop, O of n times. And so the time complexity is O of n, and then the space is the stack, so it's O of n as well, because it will contain at most the number of asteroids. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.